Now that we know whether or not a relation is a function, I want to talk about domain and range. Domain is a set of all the inputs, or if it's an ordered pair, it's that first component, it's the x values. The range is the set of all the outputs, or the y values. So now, if I want to determine determine the domain and range of a function, I look at a couple different things. So here, we did this one previously, we said yes, it was a function. So the domain is going to be every input. So Arkansas, Texas, Oklahoma, Oregon. I'm going to use these little squiggle brackets to show that it's a set. All of these values are in that set. The range is going to be the set of outputs. And it's only going to be the values that I actually use. So 4, 32. I didn't ever use 10. It's not part of my range. 5. Okay, so there's my set of inputs, my set of outputs, the range, or the domain and range. Right here, we said this is a function. So let's look at the domain and range. It's going to be the set of values -3, 1, and 2. The range is going to be the set of values 7, 7, 2. So if I see a repeat in the range, I don't need to write it twice. I'm just going to write 7 and 2. Those are the only values that I hit. Going down to our next set, that was a function. Here, remember the x is the input, the y is the output. So for my domain, the values I used were 1, -3, and 5. Sometimes it's a little bit more standard to write small to large, so you might write -3, 1, 5. I particularly don't care. So again, I see a repeat here. I'm just going to write 7 once. Okay. Now, those were sets that were finite, meaning there was just a specific number of ordered pairs or sets here. What if a graph is what we call unbounded, meaning it goes on and on and on and on forever? So the domain of a graph, the domain is the inputs or the x values. So looking at this coordinate plane, the x values are how far left and right a graph goes. The range is the y values, the outputs. And that's going to be represented by how far up and down the graph goes. So if I want to know the domain of this linear equation, I want to know how far left and right it's going to go. This is going to go forever. So if I continue this graph out, it's going to keep going left and right forever. So I'm going to use negative infinity. This is going to go in the negative infinity direction, in the positive infinity direction forever. And when we talk about sets, and this is called interval notation, I'm always going to use parentheses around infinity. Infinity is not a number, so it can never be included in a set. The range is going to be how far up and down. Again, if this graph continues forever in both directions, it's going to keep going up and down forever. Alright, we said this one was a function. So looking at the domain, how far left and right, these arrows indicate it's going to go on and on forever in both directions. The range, since this is a constant function, it's not getting higher or lower ever. It's a horizontal line. So it's going to be just one single point. This is not the best graph. x is not a nice value here, but let's just say it's 1.8. I'm just making that up. Your graphs should be something nicer. But I'm going to use these brackets to show that I'm including that as part of my range, and that's the only value. Okay, I'm not getting higher or lower. For every point on this graph, the x value will change, but the y value will not. Alright, here, same thing. The domain is going left and right forever. Negative infinity to infinity. It's going to go up and down forever. Negative infinity to infinity. Here, this is a different sort of graph. It's going to have different range for us. So we're going to pretend that this graph is going to go on and on forever in both directions. So it's going to keep going left, and it's going to keep going right. So the domain is everything. But the range is not everything. Notice it's never getting higher than this point. And it's never going lower than this point. So the highest it'll be is 4. And the lowest it'll be is -4. So I'm going to go small to large, because that's how we write in interval notation. So the smallest value is -4, and the largest value was 4. And notice that if I were to draw this graph, I never have to lift my pencil. I can just keep going forever and ever and ever, and I never pick it up. So I'm going to hit every value between -4 and 4. I'm going to touch all those different heights, all those different y values. So this is the set -4 to 4, including -4 and 4 in my set. Alright, so this is called interval notation. If you're ever asked to write it in set builder notation, like on your homework, the set builder notation will say the domain is the set of x's such that, and they want you to write it as an inequality. So in this case, you would just say -infinity less than x less than infinity, close it out. Okay, so on your homework, I believe the only piece you have to type in is here. And again, because we use these parentheses, we're going to just say less than. So that says that x is between -infinity and infinity. Now the range, if you were to type that in on your homework, is the set of y values. So be careful that you're making sure to use the right letters. X is the input, y is the output. So the y value is such that, now we're between -4 and 4. So -4 less than or equal to y, again make sure you write the correct letter, less than or equal to 4. Again, you just have to write in this inequality part here on your homework. And because we included it, so it does get to 4 and -4, then we're going to include it using this less than or equal to bar. Alright, what if I had a set of just points? So here, I would have to pick up my pencil to get from point to point. It's not a continuous line that I can just draw. Well, here I'm going to use that set again, where I just list. Okay, so the domain, I'm just going to list all the values in the domain. So 1, I went over on the x-axis to 2, 3, 4, 5, and 6. 2, 3, 4, 5, and 6. I have to list them all individually because it's not a continuous path. There's no points between 1 and 2. So I can't say between 1 to 2 or 1 to 6. There's nothing here. So I just listed all the x values that I do hit. The range, let's see, I am hitting 3, 1, -1. 2, 0, and 6. So I'm going to list all those in my range. I went up to 3, up to 1, -1, 2, 0, and 6. So again, just entering all the x values of the components of these ordered pairs and all the y values. And only those. Okay, it's not an interval. It's not between these values. It's only these specific points are in my domain and range. Okay, so here I have an x squared function, quadratic, parabola, and I want to list the domain and range. So the domain, again, is how far left and right. If I imagine this picture continuing left and right forever, it's going to get wider and wider and wider, so it's going to go left forever. It's going to get wider and wider and wider, so it's going to go right forever. The domain is everything, -infinity up to infinity. The range is going to be the lowest to the highest point. So lowest is here. And then it's going to go up, 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 up forever. So the lowest point, which I am including, because it does hit this point, is -1. And it's going to go up forever. So I'm going to say up to positive infinity. This was not a function. Let's go down here to this absolute value equation. I can just recognize it by its V shape. The domain is how far left and right. Again, I'm going to imagine this is extending forever. So it's going to go right forever, it's going to go left forever, it's going to hit all the x and y values. And again, because it's continuous, meaning I never have to lift my pencil to draw it, it's going to hit all the points in between there as well. The range, so the lowest to the highest, the lowest point looks like -3, and it's going to go up forever, so up to infinity. And just to practice again, if I had to write this in my set builder notation, the domain would be the set of x's such that, again, it's going to be -infinity up to infinity, using the less than, never equaling infinity. And the range would be all the y values, starting at -3 less than or equal to, because I'm including -3 as part of my answer, and up to infinity. Again, just using the less than here because I'm not including infinity as a number. Alright, here I've got a square root function. I've actually given you the whole equation here, but let's just talk about the domain and range. Domain, how far left and right? So the furthest left I see is right there, which is at 1. And since I've got a closed circle here, I'm including 1 as part of my answer. And then I'm going right forever, so up to positive infinity. The range is the lowest to the highest. So the lowest point I see is right here at 2. Again, it's a closed circle. I'm including 2 in my answer. And then it's going to go up, up, up forever, up to positive infinity. I have one last set here that I want to talk about, and that's these little piecewise functions, meaning you just have a piece of it. So the domain and range of something like this is the same. How far left and right is the domain, how far up and down is the range. And then you have to ask yourself, am I including the endpoints in my domain and range, or am I not including it? So if I'm including something, I'm going to use the bracket to include, or parenthesis to not include, saying I'm going up to that point, but I'm not including it. And that depends on whether I have a closed circle or an open circle. Alright, so domain. How far left and right? The furthest left I see is -1, and I have an open circle. So I'm not going to include it. I'm going to say I'm going up to that point, but not including it. From -1, it's a continuous line, so I can put in interval notation. The furthest right I see is 2. Now that one is a closed circle, so I'm going to include that in my domain. The range, how far up and down, starting at the lowest point to the highest point. So the lowest point I see is right here at 3. At the closed circle, I'm going to use a bracket. So -3 is the lowest. The highest is at 0, and that's an open circle, so I'm going to use a parenthesis. If I had to write this in set builder notation, I'm just going to write the inequality part, but it'd be from the the furthest left, so -1, less than, because it was a parenthesis, x, less than or equal to, because it's a bracket, 2. The range will be the set of y values, which will be the lowest point of -3, less than or equal to, again with the bracket, I'm including that in my answer. Y, remember the range is the y values, how far up and down. Less than 0, again because of that parenthesis. Let's try one last one. So here I've got this kind of piece of a parabola, and I want to know the domain and range. So the domain, again, how far left and right. So looking at the x-axis, I see the furthest left is -2, and it's closed, so I'm going to use a bracket. The furthest right I see is 1, and that is an open dot, so I'm going to use a parenthesis. Again, this is a continuous function. I never have to lift my pencil to get from here to there, so I'm going to hit everything in between there. That's all part of my domain. The range are the set of y values, how far up and down. So the lowest point I see is here at 0. On the y-axis, it's 0. Closed dot, I'm going to use a bracket. The highest point is here at 4. And now I am including this. This is part of my graph. So I will use a bracket here as well. So just because this is where it starts and this is where it ends, doesn't mean this is part, or this is the opening or the end points of the range. Okay, so the lowest point was 2, the highest point was here at 4. Now this is still in the range, right? That's still it's still between 0 and 4, it's still there, but this is the highest, so that's the end point of my range. If I write this in set builder notation, again I'm just going to write the inequality piece of it, but it's the set of x's such that -2 is less than or equal to, bracket, x, less than, so the parenthesis, 1. The range is a set of y's, so 0 less than or equal to, because of the bracket, y less than or equal to 4. Now, you might say, well, this was an open dot here, so 3 is not part of this graph. The height of 3 is not part of the graph. And that's not true, because over here, at this height, we do have a value at 3. So everything between 0 and 4 is going to be in the range. So all of that is in the range. Alright, if you guys have any questions, just let me know.